Okay, problem number 4 is going to be a free body diagram, and I'll go ahead and tell you it will be a circular, right? A normal tangential problem. It'll be worth 20 points. All right, and this is a good one to look at. So this amusement park ride is swinging, spinning around the gondolas on a horizontal circular path. So do you see how we can't really see it. It's coming into and out of the page, but it's spinning in a horizontal path. It is not, sometimes, problems that kind of look like this will be spinning in a circle. It's not this one. It's not a vertical path. It's a horizontal path. All right, each gondola has a mass of 200 kilograms. The gondolas assume an angle of 60 degrees with vertical. Calculate the speed of the gondola. So I want you to draw a free body diagram of just one of these. All right, so let's look at this one right here. It has weight 200 times 9.81, and then this tension right there at 60 degrees. If that's 60 degrees, this is 30 degrees, or this is 60 degrees right here. Okay, and don't add any forces that aren't really there. Don't add a normal force just because you think it's in the normal and tangential direction. Normal forces are only of one thing touching another, like the ground touching this. The ground is not touching this. It is in the air. Weight acting down, tension is acting right in there. Now, let's define our normal and tangential directions. Normal is into the curve, right? Normal is into the curve. Normal would be right here, right? Into the curve right here. If we look at this free body diagram, it would be into the curve right there. Normal is into the curve. Tangential would be actually into the page, and Z, I'll call it Z, our other direction would be that one right there. So drawing a good free body diagram, drawing your axes, labeling your axes, normal, tangential, and the other one correctly is important. So then we'll sum the forces in the normal direction. Sum the forces in the normal direction, sum the forces in the tangential direction, right? That's what we're doing with all these problems. Sum the force in X, sum the force in Y. If it's in a circular path, we're going to want to sum the forces in normal because that's where my acceleration is, right? I like to define my axes according to the acceleration, and I know there's normal acceleration, so define my axes and sum the forces in normal if it's in a circular path. So this would be, let's see, T, the sine, right? T sine 60, and that's it, equals M A normal. What is A normal? A normal is V squared over rho. So this equals M V squared over rho. This equals 200 V, I don't know, rho. All right, rho is the radius of curvature. Rho would be the distance that this object is from the center of rotation, right? That would be this length right here, right? That would be that length right here. Now be careful. Let's see. This 10, let's see, this would be 10 sine 60 just from here to here, right? Looking at that triangle. But then I also have 3. So this would be 3 and 10 sine 60. So whatever that value is, right, that would be the rho, the radius of curvature. That equation has 2 unknowns, so I'm not going to try to solve right. Well, let me go ahead and go to my other direction, sum the forces in Z. T cosine 60 is pointed up, and then the weight, 200, 9.81, all of it is pointed down, and that equals MAZ. Is it accelerating in the Z direction if it is going at this, horizontal circular path? It's not going up, it's not going down. No. So this is 0 acceleration in the Z direction. All right, so then I can get the tension, 39.24 newtons. Plug that back in up there, and I would get the velocity, 14.07 meters per second. All right, get the velocity, 14.07 meters per second. So this problem, you're going to want to draw the free body diagram, draw all the forces and only the forces that are acting on it, label the axes, and then some of the forces according to those axes, remembering that I'm always going to have normal acceleration, even if it's not speeding up or slowing down, right? This has a constant speed, but I still have this normal acceleration of v squared over rho, right? And then solve for your unknowns, okay?